Hey guys, today we are going to discuss the big picture and more precisely insight and ideation. So our producer at Kado is Jagannath. Jagannath, welcome.
Glad to be here. Now, at Cardo, we show you how to decompose a top level problem into smaller pieces and solve that. Let's get started.
Okay, Jack. So the first step is about insights, right? So can you explain it?
So, insights are about knowing what you know. It's any knowledge that your team possesses. So, your team could have been working on this project, or they could have been working on projects similar to this. It's accumulating all the know how and information and insights that they've gathered as part of those things. It's also about looking outwards on the internet, maybe hiring external experts or expertise in vendor organizations, but bringing all that together to bear for your project. And it's also about knowing which of these things is relevant and prioritizing those things and incorporating that into your designs. For smart buildings, there's three things: biometrics, complexity, and crowds. We'll see each one in turn.
Okay, so can you talk about biometrics and why using them?
Yeah, biometrics, we have a design pattern in our course. It's called Start with Molecules, Not Atoms. So, what we're saying is that when you're trying to solve a complex problem, you start with a smart starting point. You start at a place that's actually better than just a random coin toss. And that's smart initialization. You see this a lot in machine learning, for example, neural networks. When you initialize it, there's certain ways in which, for some problems, if you initialize it, you might get better convergence compared to just a random initialization. And also in design, you see this. Sometimes the building blocks that you use, you use prefabricated pieces. You don't start from scratch. And the idea with that is combining larger pieces into something that works is simpler than starting with the elementary atomic pieces. That's the idea of using biometrics for this problem. Because what biometrics does to phases and surveillance is that it simplifies and gives some structure to a face. It makes it easier for a machine learning model to recognize that instead of just having a simple and pure vanilla face to work on. Of course, face recognition is a standard problem in machine learning. We feel that if you incorporate biometrics, your problem is simplified. It is a simpler representation in the sense that it provides a certain type of structure to your face, and all you need to do is replicate that and recognize that, as opposed to all the finer features and details of the face. So in that sense, your neural network or whatever model you use could potentially be simpler to set up and easier to troubleshoot and potentially more stable in terms of convergence when you train it every time.
So the smart building problem and surveillance in our case is complex. Can you describe how?
Yeah, it depends on the size and the function of the building. Size. Take, for example, a strip mall with, say, 5 stores. What you're going to find is people are going to park outside the store they want and just use that store. So it's not really a mall, it's just a collection of stores. That's probably a simple scenario. Contrast that with a large facility with 50, 100 stores, many restaurants, parking lot, movie theater, maybe office spaces, maybe residential spaces. Now that's a complex. People are going to go there for different reasons to do different things. And a lot of people are going to be going there, say, during the week, on weekend nights, on a Sunday. So all these things are going to vary based on the size and the function. The latter, with the large complex, you are going to get many more scenarios to work with. And so that's the sort of thing that defines complexity in a smart building. The other thing could also be, say, modeling level. With the large facility, for example, right? If you are looking to get global metrics like the total footfall or the number of people and stuff like that, the number of customers, the number of through the mall, that sort of thing. At that point, you may just want to model stores as nodes as and have them as an interconnected graph. And this way you can simulate overall traffic in the mall. This is not granular because you are still looking at the global picture. If you want, for example, to get one level down, you could model individual stores and what happens inside them. So in that situation, what you would do is you would set up like shelf spaces, displays. People are going to go into the store. Maybe they want to just browse. Maybe they want to browse, explore, and buy something of interest. Or maybe they already know what they want to buy. So the different scenarios, and then they want to buy, pick those things up. They want to pay, and they want to leave, and so on. So that level of modeling is one level below from what we just said as the global picture. And there could be a third scenario where you combine the two. So depending on what you're looking for as the modeling objective, that also makes your problem complex.
So size, function, and modeling, what other insights do we need to consider?
Crowds and crowd behavior. Okay. This one way of modeling it is you create the model of an individual, you scale that up to model a crowd, and then you incorporate features like poses and biometrics to model crowd behavior. The other way of doing it would be to just learn behavior from video and data on crowds. That's the other option. With the former, it's more work because it's three different models, but you get more control. And if something goes wrong, it's easier to troubleshoot. With the latter, it could be just a single model you're working on, and it could be easy to do so. But sometimes you might find that it does not learn very well. And even if it does learn well, you are in a black box situation, so it's hard to troubleshoot. So that's the trade-off between building it atomically or just building a single thing, a single model, and learning all of it and doing all of it in that single model.
Okay, let's move on. So what do you do with the insights you possess?
So once you've gathered insights, the next step is ideation. Our problem, our main goals are surveillance and incident response. What that means is I want to be able to know if someone's in a part of a building that they're not supposed to be in. I want to know who's where in the building. So that's surveillance. And the way you do that is from facial recognition models of individuals, you capture biometrics, and then you know, and you tie that to a person, and then you know who is where in the building. Now, there's also incident response. If there is a crowd and the crowd is up to something, maybe there's a fire and people are exiting the building, or there's a large group of people in a place where they're not supposed to be. Maybe they just gather in the halls, having a party or something. The building needs to be able to formulate a response for that. So, A, it needs to model the crowd behavior, and B, it needs a representation of the rules and regulations so it knows what to do. So, these are the two things that we are modeling: surveillance and incident response. So, let's see how it comes together. Our end goal is the preventive security engine. And that's really what we are working towards. We want to start there for ideation and work backwards step by step all the way to the inputs to get our overall flow, or at least the first iteration of it, right? What we are seeing here is that the preventive security engine has two inputs. One's the surveillance system and the surveillance model and the behavior model. The surveillance model, what it does is it takes facial biometrics as input and determines who is where in the building and whether they're actually supposed to be there or not. It also needs input from the crowd model. It's set up to work on an individual and recognize individual faces, but it also needs to do that in a crowd. So the crowd model feeds surveillance. The crowd model also feeds your behavior model. So what you need to know is if there is a crowd in the building, maybe it's part of a fire drill, Maybe there's an actual emergency and everyone's exiting the building. Or maybe people are out in the halls because it's an occasion and it's a party. Okay. So these things, right? The different types of behavior of a crowd in a building, that needs to be modeled and captured and sent along to the preventive security engine so it knows what to do. And then finally, all your building sensors, they also feed the preventive security engine and allow it to do its job. Let's look at a couple of more pieces. Firstly, the crowd model. How is that developed? Okay, it needs a couple of inputs. Firstly, it's a logical representation of the building, so spaces and how they're connected together. This information is usually available in blueprints and floor plans that's available in a building information management system. So BIM, building information management, this is something that's bread and butter. A lot of modern buildings have such a system. The information in there is in different formats. We extract that and we create this logical representation of the spaces and how they're connected, and we feed that to the crowd model. Also, the crowd model needs a person detector. In order to create this person detector, we've got video feeds both from the common areas as well as the restricted areas. The person detector, the job of it is to detect the existence of a person in a location. Okay. Now, once you get those two, the crowd model also needs motion sensor data or alternate sensor data in places where there are no videos, like locker rooms, for example, or toilets. And once you have all these things, it can then do its job. Also, the preventive security engine, okay, in order for it to function, it requires some sort of representation of rules and regulations in the building. Okay, these are available in a digitized form. Okay, we use natural language processing to extract these things and put them in some sort of knowledge base, could be an ontology or any knowledge representation that's suitable would do, and that serves as input to the preventive security engine. Finally, the security engine also requires the logical representation of the building. It needs to know what the spaces are. It needs to know how they're connected. That's like building the skeleton. That's like basic for it to understand what is the building. So the BIM building model output that we created also feeds the security engine. And then what else have we got? Our basic foundation for building a surveillance model is to use access biometrics. So this is available usually in access control systems, in access control databases in buildings. We extract that and we extract the biometrics from that, and we use that as the input and the basics to build the surveillance model. But in order for it to function, it also needs a real-time view of what's going on in the building. So what's happening in the restricted areas, maybe in the common areas, but mainly the restricted areas, it needs to know that. Okay, that's also an input to surveillance. If there's a crowd, okay, if there's a crowd forming in the building, particularly in a restricted area, and many of the people in that crowd have access to that area, but a couple don't, right? That the surveillance model also needs to be able to suss out. So in order for that, it needs the crowd model as input. And then finally, access control information, it just that's also something that it needs. Um, yeah, so that's all the stuff that we use to build the surveillance model. Like we talked about before, right? Best in class facial recognition systems are deep learning based. Right? You technically do not need biometrics, right? We use biometrics and we are recommending that because it simplifies the problem. You start with a standard best practice representation that simplifies your data and your space, and it makes for learning to be easier, and it makes for easier troubleshooting if something does go wrong. And that's kind of why we recommend to use biometrics in this situation. You can totally ignore that and you can just go with something that's pure learning based, and that's fine. But even if we do use biometrics, we still need a learner there to learn the biometrics, right? So that's a learning method is probably still your foundation for the surveillance system. Okay, one other piece. In order to develop your behavior model, you need a pose identifier, right? The behavior model gets a crowd database, right? The crowd database is used to provide different scenarios, but in order for it to know what's going on, in order for it to know that a person has a particular pose or is about to do a particular thing, it needs a pose identifier. Okay, so the pose identifier works on individuals. There's a crowd model, and the behavior model combines these two in order to understand and extrapolate what the crowd is doing. Okay, and then that feeds the preventive security engine. So as you've seen, there's a lot of pieces, right? They come together. Many of them are dependent on the outputs of other pieces that we've developed, and that's great. Having an approach like this, where you've got pieces and they provide the input to other pieces, and then you work from one end all the way to your objective, that is good. And it's better than developing a large monolithic model and something that acts like a black box. And here's why. Okay, the black box might be simpler to build, right? You're just talking about one large model and one huge architecture, and you can just do that. If it works, great. But what if it doesn't, right? How do you troubleshoot where you went wrong, right? For a system as complex as this, learning methods may or may not be powerful enough to learn all the different scenarios and do all the different functions that we wanted to do. So in that situation, having these different pieces is great, because now you can swap different methods in and out. In this lay of the land, there's going to be many pieces that are learning based. Like learning is going to be your foundation for smart buildings, because the primary input is data, which is CCTV feeds, images, access control data, and so on. But there's also going to be simulations. It's also going to be a couple of solvers. And you can always look at it and say, maybe I can swap these in and out with other types of methods. Okay. And that way you have control, you have options when you're crafting a solution. And that's why we would recommend doing something like this instead of just putting and throwing a large monolithic model at a problem like this.
Thank you, Jacques, for the explanation and all the knowledge you shared with us today. And thank you guys for watching. If you like this video, please don't hesitate, just like and share. Also, you can find our website just below, where you can also take the test to see how the hero methods can help you. So thank you again, and see you next time.
Bye-bye.
Ciao.